For centuries, humanity has gazed up at the night sky, charting the movements of the planets. Mercury, the swift messenger god, has always fascinated us. We sent probes like Mariner 10 and Messenger, but they only scratched the surface. Now, the James Webb Space Telescope is changing everything, peering at Mercury with its powerful infrared eyes. The data reveals Mercury is far more complex and dynamic than we imagined, a survivor of cosmic chaos. The story of Mercury is a humbling reminder of our own fragile place in the universe. Mercury is a planet of unimaginable extremes. Its sunlit side bakes at over 400 degrees, hot enough to melt lead, while deep craters at the poles remain in permanent shadow, plunging to 170 degrees Celsius. Fire and ice exist side by side here. The James Webb Telescope's infrared vision lets us peer into these hidden, frozen pockets, revealing secrets old probes only hinted at. For decades, finding water on Mercury seemed impossible. How could ice survive where the surface is hot enough to melt lead? But NASA's Messenger found evidence of water ice hidden in Mercury's shadowed craters. Now, the James Webb Space Telescope is confirming vast frozen water mixed with mysterious dark material. JWST reveals this dark layer is rich in organic compounds, the building blocks of life, delivered by comets and asteroids. Mercury, once thought barren, preserves a record of water and organics, echoes of the ingredients that may have sparked life on Earth. Mercury's enormous metallic core is a mystery. It makes up 60% of the planet's mass, double Earth's proportion. This dense, metal-rich world shouldn't exist according to our planet formation models. The leading theory? A giant impact stripped away Mercury's crust, leaving the core exposed. But new data from the James Webb Telescope shows Mercury still has volatile elements, evidence that challenges the simple impact story. The truth is, Mercury's origin remains a cosmic enigma. Mercury has a magnetic field, a mystery for such a small planet. Normally, a planet's magnetic field comes from a molten core, but Mercury should have cooled long ago. Yet, Messenger confirmed Mercury's field is real, forcing scientists to rethink everything. The answer may be sulfur in its core, acting like antifreeze and keeping it liquid. The James Webb Telescope could soon confirm this, revealing Mercury's true, mysterious nature. The surface of Mercury is a brutal landscape, a testament to a long and violent history. It's covered in countless impact craters, from tiny pockmarks to vast, continent-sized basins. The largest of these is the Caloris Basin, a monstrous crater stretching 1,550 kilometers across. This feature was created by an asteroid impact so powerful it would have dwarfed the one that wiped out the dinosaurs on Earth. The shockwaves from this single event were so immense that they traveled through the entire planet, creating a bizarre, jumbled terrain on the exact opposite side, known as the Weird Terrain. Mercury is a planet that was literally shaken to its core. But the craters are only part of the story. Crisscrossing the planet are enormous cliffs called lobate scarps. Some of these cliffs are hundreds of miles long and over a mile high. For a long time, scientists have understood that these scarps are essentially giant wrinkles on the planet's surface. They formed as Mercury's massive iron core slowly cooled and contracted over billions of years. As the core shrank, the planet's crust was forced to buckle and break to accommodate the smaller volume. Mercury is, quite literally, a shrinking planet. The James Webb Telescope is now studying these scarps in a new light, infrared light. This allows scientists to analyze the mineral composition of the rock exposed in these cliff faces. The cliffs act like road cuts, giving geologists a cross-section of Mercury's crust. By studying the minerals, JWST can determine how old different parts of the crust are and how the cooling process has unfolded over time. This is helping to create a much more detailed timeline of Mercury's geological history, revealing a planet that has been far more active for far longer than previously thought. The terrifying truth that JWST is helping to uncover is that Mercury is not geologically dead. The Messenger mission found evidence that some of these scarps are surprisingly young, suggesting the planet is still contracting today. This means Mercury is still tectonically active. It likely experiences Mercury quakes as the crust continues to shift and break. The image of a static, unchanging world has been shattered. Instead, we see a dynamic planet that is groaning and cracking under the immense strain of its own cooling. It is a world that is slowly crushing itself, a grim reminder of the ultimate fate that awaits small, rocky worlds. The discovery of both water ice and complex organic molecules in the permanently shadowed craters of Mercury is one of the most profound findings of the James Webb Space Telescope. Organics are carbon-based compounds, and on Earth, they form the chemical foundation for all living things. Finding them on Mercury, the sun-scorched innermost planet, is both shocking and incredibly exciting. It's important to be clear. This is not evidence of life on Mercury. The conditions on the vast majority of the planet are far too extreme to support life as we know it. But it is evidence of the ingredients for life. These organic molecules were not created on Mercury. Instead, they are ancient relics from the dawn of the solar system. They were delivered to Mercury over billions of years by comets and carbon-rich asteroids. These cosmic messengers are like time capsules, carrying pristine samples of the primordial material that formed the planets. When they crash into a world like the Moon or Mercury, which have no atmosphere to burn them up, they deliver their precious cargo directly to the surface. In most places on Mercury, the sun's intense radiation would have quickly destroyed these delicate molecules. However, inside the deep, dark, and frigid polar craters, these organic molecules found a safe haven. Shielded from the sun and preserved in a deep freeze, they have survived for potentially billions of years. Mercury has unintentionally acted as a giant cosmic freezer, preserving a perfect sample of the building blocks of life from the early solar system. By studying the specific types of organic compounds found there, scientists can learn more about the chemical inventory that was available when life first began on Earth. It is a direct window into our own planet's distant past. The terrifying and awe-inspiring implication is that the raw materials for life are not rare or special. They are everywhere. They are scattered throughout the solar system, delivered by comets and asteroids to every planet, from scorching Mercury to the frozen worlds of the outer solar system. This suggests that the potential for life to begin may not be a unique miracle of Earth, but a common cosmic possibility. The only thing that might be rare is finding a place like Earth with the perfect Goldilocks conditions, the right temperature, a protective atmosphere, and liquid water, where these ingredients can come together and spark the miracle of biology. The James Webb Space Telescope reveals Mercury as a survivor of cosmic violence, a battered world with a giant core, shrinking crust, and secrets locked in icy darkness. Mercury's existence defies our models, reminding us the universe is chaotic and unpredictable. Water and organic molecules are frozen in its polar craters, a hint of life's ingredients, but also a warning of fragility. Mercury's story is a cosmic warning, making us appreciate just how precious and rare our own existence is.